Hi lads, how are you keeping? Welcome back to AnderMaxPC. Today on the bench we have a Gigabyte RTX 3060 Gaming OC Rev 2.0. I'm lucky because I bought this card secondhand in good condition, and as I found out later, it has Samsung memory. It's a really grand option for overclocking. It still has the factory warranty seal intact, but underneath this massive triple fan cooler, there's a serious thermal transfer issue we need to address.
Baseline telemetry. Stock idle sits at 50 degrees core, 61 hotspot. Under Furmark, the core hits 74, with the hotspot peaking at an alarming 92 degrees at 80 FPS. I applied a 925 millivolt undervolt at 1800 megahertz. Idle drops to 40 core and 60 hotspot. Furmark load temps improved to 65 and 79, but performance up to down to 68 FPS. The thermal interface is dead.
Well guys, let's now take apart the graphics card and see what's inside. I'll tell you in advance that I'll use a hybrid method for replacing the thermal interface. If you're interested, watch to the end and you'll see what materials I used for this graphics card.
All right, let's get inside this card. Unscrewing the back plate one by one, we can finally separate the board from the massive heatsink. You have to be very careful here. Using a thin screwdriver, I gently disconnect the three headers, 2 for the fans and 1 for the RGB. Ripping these wires out by accident is a nightmare you want to avoid. And here is the exact reason our hotspot was boiling at 92 degrees. Look at this. I'm scraping it with a screwdriver, and the factory thermal paste on the GPU core is completely bone dry. It's turned into dust. But it gets worse. Look at the memory thermal pads. They are absolutely soaked in oil, bleeding silicone all over the PCB. You can literally see the grease shining on my fingers. The thermal transfer here was effectively zero. We cannot put new high-end materials on a greasy board, so let's get this mess cleaned up. I start with a simple toothbrush to carefully break away the dried paste from the chip. Then, I use a specialized flux remover I got from AliExpress, Conduction CDX-01. This stuff is magic for cutting through thick silicone oil. Now, for the moment you've been waiting for. We promised you our custom hybrid method for the thermal interface, and here it is. Why hybrid? Let me explain the physics. For the VRAM and power delivery area, we are using standard, high-quality 1mm Gelid pads. That gap is standard. But for the memory, Gigabyte uses a very tricky 0.75mm gap on these specific cards. If you use standard 1mm pads on the memory, they are too stiff. The heatsink will sit too high, it won't make proper flush contact with the main GPU core, and your hotspot will instantly skyrocket. If you use 0.5mm pads, the memory will overheat. That's why we use Thermal Grizzly Putty for the memory chips. With my black latex glove on, I scoop out the putty. I warm it up with my fingers to make it pliable, like clay, and apply it evenly across all 6 Samsung memory chips. When we mount the cooler, this putty will squish and compress to the exact 0.75mm thickness we need. No gaps, no pressure issues. Then I measure, cut, and stick the Gelid pads for the VRM, and apply a fresh layer of premium Thermal Grizzly Cryonaut directly to the GPU core. By the way, lads, if you're still watching and finding this useful, please don't ignore the like button. Taking just a second to drop a like and subscribe really supports me and helps this channel grow. Turn on notifications so you won't miss the next deep dive. All right, back to the rebuild. Time for reassembly. I reconnect the 3 headers, carefully align the heatsink, and flip the card so the back plate is facing up. Checking the alignment is crucial here. Now, the most important step, I tighten the 4 main leaf spring screws in a diagonal cross pattern, just a little at a time. This forces the cryonaut and the thermal putty to spread and compress perfectly evenly across the entire board. Once the core is secure, I tighten the rest of the screws. You can see a tiny bit of excess thermal putty squeezed out right near the PCI Express contacts. I carefully trim that away and wipe it clean. You never want anything obstructing the PCIe slot. And with that, she is fully rebuilt, fully optimized, and ready to go. All right, the moment of truth. The card is installed into a newly assembled PC ready for sale. Let's immediately launch FurMark and see what our hybrid method achieved.
Wow, just look at this. After 5 minutes of a brutal QHD FurMark run, the GPU core is sitting at a beautiful 58 degrees and the hotspot is just 69 degrees. Remember, that hotspot was screaming at 92 degrees earlier. Our FPS is holding a steady average of 69 frames. The thermal transfer issue is completely resolved. But we are AnderMaxPC, and we don't just stop at stock settings. Now that we have massive thermal headroom, let's optimize. I'll put the exact MSI Afterburner settings on the screen for you. We reboot, launch FurMark again, and boom! In QHD, we see 77 to 78 FPS, up from 70 in stock. Dropping to full HD, we see a rock-solid 107 to 110 FPS. Let's push the efficiency even further. But first, we run the GPU-Z render test and see even lower temperatures. Now, let's run some synthetics. 3D Mark Time Spy gives us an impressive 8,149 points, with the GPU never crossing 62 degrees. 3D Mark Steel Nomad in QHD yields a solid 1,980 points. Now, let's unleash the beast. Time for the ultimate tune. We dial the curve to 1,837 MHz at 937 millivolts. Because we know we have Samsung memory, we throw on another 100 MHz, making it plus 900 in total. And crucially, we raise the power limit to 110%. The results are incredible. 3D Mark Time Spy jumps to 8,279 points. Steel Nomad breaks the 2K mark with 2,006 points. And the Superposition 1080p Extreme benchmark delivers a massive 5,259 points. This stable setup suits me perfectly. I'm not going to chase record-breaking numbers in benchmarks. I'd rather test the FPS in a couple of real games. Let's look at real-world performance. First up, Hogwarts Legacy in QHD. In a heavy combat scene, we push between 110 and 130 FPS with a flawlessly smooth frame-time graph. The CPU is at 61, while our fully loaded graphics card chills between 50 and 60 degrees. And finally, the super-optimized World of Tanks in QHD. We see a blazing fast 180 to 195 FPS. The frame time is a perfectly straight line, and the GPU temperature refuses to go above 62 degrees. From a thermal throttling piece of hardware to an absolute ice-cold powerhouse, I consider this an outstanding result. If you enjoyed this rescue, drop a like, and I'll see you in the next video.